I know I
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Okay. I think it's working now. All right. Yes. Yes. There we go. After we ruined it. Oh, wow. That was such a boomer move. This is what happens when you rely on technology and you actually don't double check. Okay. There we go. Thank you, Tim. Thank you, Rick. Thank you, Mark, for everybody letting me know. Wow. These are the very basic things that you're supposed to do. Let's actually see. How should I be? Let me see. Okay. I want to. Wow, I'm literally just going on, and there was no audio. Thank you, everybody. See, okay, okay. I think I've lost the right to make fun of Culture Casino for boomering it so long. They'll go on a rant, and all of a sudden, like, oh, I think people are here now. What does everybody say? No sound, nothing. Yes. Thanks, Mark. Okay. Yes. That's Oh my God, look at this. Look at how silly I look. Hold on. Uh, uh. I feel like I'm so happy. I'm just like, oh, I'm talking about the stuff and things. I'm going on a great little tangent upon tangent upon tangent, and no sound is coming out at all. Oh, all right. I think we're all right, we're no. Okay, cool. Oh, that was a good one. All right. There we go. Yes, yes. All the oscillation from my voice was just being absorbed into something that's totally not the ether. Okay, we can close that. All right. To recombobulate what I was talking about, user's note from last Wednesday, I said something totally wrong. Basically, I hold on. Basically, I thought this was the same as cotangent of 7. Why do I say okay? 6.9524, blah blah blah, versus cotan of 1/7, 1/7. Okay, 6.952. Okay, it's a 3 instead of a 4. All right, it was still at 1 sigma. This one is a better fit. It just doesn't pop up until you put in the full like 7 or 8 digits, or at least for me it didn't. So again, I was promoting fake conjectured science. I mean, unless we need to adjust something, we just go through and just use this as a model for the Planck length. Okay. So it actually should be sine h of sine h of 1/7, the inverse of that. Cool? Groovy. All right. I think maybe 2 people might know what I'm talking about, but that's okay. That's okay. This is how we learn. And hey, it could be just completely tragically wrong, but we go from there. All right. Let's go to our friends. Hold on. Go to our window. That's how we do it. All right. Oh, maybe I should actually start to speak words again about what we're actually going to be talking about. All right. So you didn't even hear my horrific excuse why I played that clip and then didn't even appear because I was making more coffee over there. All right. So, boomerang aside for today, at least for the moment. All right. What are we talking about today? We're going to do a little bit of a Black Hole Friday special. Why? Because that's what we were talking about a little bit earlier, and we actually have some stuff on the board here. And I am just noticing that the standard factorization of this 1 plus I times 1 plus I actually kind of looks like a little bit of a nod if you were to cross over and stuff. So, okay, that's just a little thing. It's okay. So, what are we? What are we going? What are we going to talk about? So, some of the things we had talked about a little bit earlier. Hold on. Let me get a little bit closer. Let's see a little bit of border better. All right. So we're talking a little bit about earlier about what are some characteristics of black holes. All right. So again, I would conjecture that rather than calling them black holes, we should be calling them mass holes. Why do I say this? Number one, Massachusetts born and raised. So I am very biased on that. I feel it would be more accurate because, to be fair, they're more as visible spheres within the fabric of space-time that seem to be preventing bad stuff from happening. Okay, because you kind of don't want to break where we live. That would be a bad idea, and I'm sure nobody would ever do that on purpose. I digress. Black holes. What are their characteristics? They appear to have mass. We seem to be able to detect mass. Why? Some distortion. It seems at the center of every galaxy, there seems to be a pretty good sized black hole. So you got a bunch of mass stuffed in there. All right. And then it seems to take up space. Why? Because we can do some calculations. We do the calculations, and there seems to be an event horizon. It seems to be an area from which, if one crosses, once you check in, you do not check out. Technically, we believe. Okay. There seems to be a notion of an inside and an outside marked by C. That seems interesting. The speed of light does seem to be speed of light in a vacuum. Does seem to be like a fundamental type of thing. Cool. And it's a temperature. The temperature, all right. At the smallest, it's 8 pi Planck temperature. Not quite the Planck temperature if you're doing a Planck mass, but it has a factor of 8 pi there. Well, that's coincidentally, I think the Hawking radiation calculation does either have 8 pi or is it 16 pi? It's 8 pi for the temperature because because the event horizon area is 16 pi because was it a Planck mass black hole has 16 pi Planck lengths. Why? You do the calculation, you get out 50 point yada yada yada. And there's a 16 pi term right there. Everything else more or less seems to cancel out to at least that factor of curvature, whatever it might be. Okay. All right. And then we seem to have time gets squeezed out by the speed of light boundary. Because what do we say? You hear these things, it's like, all right, in a black hole, there is no time. What does that even mean? Well, it's like, all right, if you're going to freeze that, all right, the coordinate flips. So it becomes all of a sudden, it becomes spatial. Does that mean it's four-dimensional? Does that mean all of a sudden, if you're going to have a gravitational collapse of something, it's going to collapse down? And what is it? It's become 4 dimensions of space? Because in 4 dimensions of space, you don't really have to worry about getting knotted or bundled up. A lot of things can just kind of pass through each other and everything. And then, what is it? Just do a full inversion like that? I mean, maybe that would explain a lot of things, but we'll work up to a speculation. I have to take off my shoes. My feet are overheating, and if I can get a little shorter for the camera, so my head doesn't get completely lopped off. I have to keep adjusting it, but temperature decreasing. That helps me think better, as long as it's within a particular range. All right. So, long story short, you go through some of these calculations. We'll do the first very basic one, the radius of a black hole. Okay, because there is a factor of 2 in there. It's a very interesting thing. So let's go over to our friend over here. I'll share with the class. Okay. So, okay, the event horizon radius. What do we got this? We got this. All right. 2G. What the heck is that? All right. So you got a factor of 2. You get the Newtonian gravitational constant there, big G. Mass is whatever mass we're going to have. So we're going to do this. We're literally just going to type in the magic words that we got from our cheat sheet, 2G. And for the mass, we're just going to do Planck mass. So a reference unit of 1. Then we're dividing that by c squared. All right, we're dividing by the speed of light squared. Divide by c squared. We pop it into our thingy there. It gives us our interpretation. So we get all these numbers, don't worry. Oh, look, we got a factor of 2. All right, so, and again, these are just the standard Schwarzschild solutions. What does that mean? That means we are not including electric charge. nor angular momentum. What is that? Basically, if you got something spinning around and everything, it's like, all right, you start spinning a charge. What's going to happen? You're probably going to see some electromagnetic stuff happen there. Oh, because a moving charge causes some deformation in the magnetic field, and then a spinning magnetic field ends up seeming to generate charge. Why? Because U1 is literally built into mathematics. That was a terrible answer. It's the broadest answer I can get because essentially, like electromagnetism, you go through all the electromagnetic stuff and then you realize if you literally just do math, you get it for free. Why? If you're curious, you should probably check out Richard Beales. I think it's Beihl. He goes through, and I'm like, oh my god, I can actually start to follow some of that. Hey, Jack, what's going on, my friend? You missed my boomer moment. I was yapping on for about 10 minutes with no audio. I just went on a complete rant, and then all of a sudden, when I finally checked chat, all of a sudden, just the first four people like, no sound, no audio, man. Can't hear you, bro. Oh, that was so embarrassing. Should I keep that in or clip that out? Maybe I'll just put a warning and a little label. Skip ahead to like 10 minutes. But okay. So what do we got here? All right. So long story short is okay, the radius of a non-rotating, non-charged, the simplest black hole, we get 2 Planck lengths. Okay. So riddle me this. What happens if we did something fancy? What happens if we include electric charge? So, you know what? Let's cheat. Let's just do this. Let's do blank mass black hole event radius. Do that. I think that should be in the correct syntax for it to what? Like mass black hole. What this? And horizon. Okay. Computational inputs. Let's just do this. Black hole radius. Boom. There we go. Simpler. No, formula. There we go. Radius. Like mass. It should just, why don't you just give me the silly little calculator? Radius of. Radius of like mass black hole. Yes. Commutativity or, oh, wow. Okay, never mind. We're just getting all types of, that's a crazy here. Okay, no, we will go to the calculator. Go back. All right. Call radius. Why won't you give it to me? Sorry, everybody. Yes. How terribly entertaining as I'm struggling with Wolfram Alpha with the thing that I literally did earlier. I call radius. Just, oh my god. What? Radius, human, average of what? Why is it math? I call. How about this? 1 kilogram black hole radius. Okay. Why don't? Oh, this is so dang annoying. It's formula. I just want to make this easier. Oh. Why are you failing me? Why are you failing me? I know this. Oh. Average of all mass. You're not. Oh. 1 kg. Black hole. Okay. There we go. All right. All right. We've got. All right. Blank mass black hole. There we go. And then we just need to add on. Oh my God. Why? No. There. This is. This is. This is hurting me. Okay. Never mind. Not enough, Jack. Not enough. Oh, we had it all. Okay. Black hole. Mass. Blank. Mass. No. No. Oh, blank mass. There we go. Radius. Okay, we'll just do it the long way. Why? Because we can. And that is far too annoying. All right, so what are we doing? Event horizon radius. All right, let's plug it in. Let's see if they got it right. All right, so we're taking the square root, yada, yada. We're plugging this whole dang thing in. All right, so g squared, like mass squared, divide by c roots to the fourth. All right, minus big G blank charge, because we are taking maximal things we claim. Square of that. All right, divide that all by, oh, this sounds familiar. 4 pi c to the fourth electric constant. Constant. All right, boom, we got that. All right, let's close our square root brackets, and then we have our standard notation that we literally just add to it. So we add, oh, there is no factor of 2 there. That is interesting. I just noticed that. Groovy. All right, G Planck mass, and then divide by c squared, boom. Will it compute, or is it too much data for it? Oh my God, it actually computed. All right. All right, so that whole dang long story, an abomination. We've gotten to the point here. All right. So basically, when we did the standard non-rotating, non-charged black hole solution, we get 2 Planck lengths. Coincidentally, if you actually include a maximal charge on it, we get down to 1 Planck length. WTF me. And basically, it does that same thing if you just add an angular momentum. So, like, if we go over to, basically, this is just what I put in here. I just put in literally the thing there because it didn't want to cooperate with me because I'm a noob. Yes, because obviously shaking your fist at a computer program makes it work better. All right, let's go back. We'll go back. Let's try angular momentum. Basically, long story short, is you're going to do the same thing, except instead of our Q term, which is a representation of charge, we're using J. What is J? Oh, it's a unit of angular momentum. What's a unit of angular momentum? I don't know. Maybe a joule a second? How about H bar? All right, so we do the same dang thing over there. Except, is it the same? Yeah, it basically looks the same, except, believe, it's G. Yeah. Oh, no, wait, hold on. Let me pull this out. I just need to compare them side by side so I don't make it even worse. All right, so we're taking the square root of G squared Planck mass squared over C4 We're okay. Because we have a different thing. So we just need over here. I got G for my numerator, H bar, and then we're dividing by, in this case, C squared, Planck, mass squared. I mean, it almost seems like a lot of arbitrary things to get things to work out, but apparently magic is a thing, or science. Any sufficiently advanced technology is indistinguishable from magic. And then G, okay. So after all that jazz there, we have all that, blah, blah, blah. Okay, where's it getting confused? Plus GM dot C squared. We're adding G squared, like C4. And then we're subtracting out angular momentum is H bar squared. Oh, it should be C squared. Ooh. What did I? Oh, there. I forgot the 2. There we go. It's amazing when you have the correct inputs. All right, so we get down to 1 Planck length. Okay. So after all that jazz, all right. Hey, Dave. Thank you for joining, my friend. Don't worry. Don't listen. Math, it's just stuff doing things. That's literally all it is. Sometimes we use numbers. Sometimes we use chicken scratch. Sometimes we'll list it as some probability. If it's more this, then it'll probably be less this. Why? Because it needs to sum to 1 or 100%, which you can do by a 1.00 if it makes you happy. But the whole point of that is your standard thing, if you're solving for a black hole, at least the radius, the point from the center where you go out after you crush all that stuff down till it's wicked small. And then you have an event horizon or whatever that may be, basically coming out. And then we have a calculation that your standard non-rotating, it's just there, if that is a thing, it has a radius of 2. Yet if you were to add, and it has a gradient going up to the maximum there, if you add in charge or angular momentum and or you actually get to the point where that radius gets smaller. It goes from 2 down to 1. But did we actually, Jack? That does sound fairly appropriate. I think even math has slang because some folks are like, we're using the Einstein summation notation. What does that mean? We leave out the summation sign because duh. Because if you do it enough, then it maybe seems a little redundant. So some could say there's some slang or maybe more efficiencies in there. But yes, it's like kind of coding in that you're trying to find the simplest way to get to it. Okay, yeah, no, I can kind of see what you're getting at. But all right, we go from a factor of 2 to 1. And that's all that this jazz with the stuff on the board, because it ends up being, if you take the calculation literally, when you put in all the stuff like a maximal charge, maximal angular momentum, because apparently you've got some things that black holes that are spinning close to the Eddington limit. What is that? So apparently the maximum amount of potential rotating close to the speed of light, that if you go much faster, we might have a naked singularity. Ooh, naked singularity. What does that mean? I don't know. Does the event horizon peel back? Is it like a spicy shower scene in an 80s movie where the black hole is like, I'm sorry. That's what happens when you spend too much time with a monk. But basically, when you do some of the calculations, you'll get 1 plus I. Okay. What the heck does that mean? All right. If you're going to an extreme, it goes down to like 1 Planck length plus 1 imaginary Planck length. What does that even mean? Best guess is, as you can see, this kind of a kind of a plus over here. It's like, all right, you got to have a Cartesian plane. If you're going to have your XY, it's like, all right, maybe there's another orthogonal plane. Maybe things are coming together. Is this why I is important? I don't know. I heard some folks talking before, and they're like, well, within probability, one is basically king. Oh, within quantum mechanics, oh, I is basically king. I'm like, wait. So if I is basically king, and quantum mechanics is the fundamental, does that mean -1 is more primal than 1? It's the old noggin a jogging. That was a little bit of provocation there. But okay, so what is the notion of having a black hole of something? All right, we have a unit of length here. We can go through. We can kind of try to calculate this. Okay, but what does it mean if all of a sudden I comes into play? I thought that was supposed to be a quantum mechanical thing. Why is it happening for things that might be larger? Well, to be fair, that was the Planck mass. That does seem to border of the realm quantum, as we saw from our little diagram the other day about the difference between the classical and quantum realm is if you're less than about 10 to the -8 meters, about the magnitude of the Planck length and mass, or greater than uh, what is it? About 10 to the 8 meters per second, aka once you're getting close to the speed of light, things seems a little bit wonky. But then you have folks like Professor Jacob Brandon that comes along and it's like, I was looking for the gap between classical and quantum mechanics. I wanted to see how close I could get to the point where we needed to hop over. And then he's like, oh, look, the gap seems to go away. The keyword terms here, my friends, are unistochastic. I would pay attention to this because it's not necessarily. I'm sure I'm the only one that's ever used the terms quantum theory, quantum mechanics, and string theory to mean the same thing. Those are three different things, my friend. Quantum theory is what happened when it's like, oh my God, we have no way to explain this. We need a better way to help model this. All right. And quantum mechanics came out of that as a way that we seem to be able to model the measurements based upon this specific cookbook and formula for doing things. We don't really know how it works, but it appears to work. Okay, cool. And then string theory would be an iteration of that, basically attempting to unite quantum mechanics with general relativity by thinking of just, oh, there's oscillating strings and everything, and oh, that's cool, that's beautiful. I mean, apparently you get a spin 2 graviton-like particle that a lot of folks seem to be looking for free. Great. What's the problem? It works in 26 dimensions. Okay, hey, if it's 26 dimensional, you can invoke the Leech lattice and probably make everything work out. Is that the best way to describe where we live? Maybe. We can get down to 10 or 11 dimensions. Okay, I can try to intuit that 10 or 11 dimensions. If you got 9 dimensions of space magically, if you're trying to pack spheres together, kind of like if you're stacking oranges and stuff like that, usually I have, I think in 3 dimensions, about 77% efficiency if you were to stack a whole bunch of oranges. In 9 dimensions, everything just automatically fills up all the empty space. So that's convenient. All right. And then if you add second dimension of time, all right, so little time, and then maybe like cosmic time, I could try to figure that out. Okay, 10 or 11 dimensions, maybe that works. Is that the best description? I don't know. Maybe if we apply a double cover to 5 dimensions of measure, maybe that's why certain things, I don't know. Is that why 5-dimensional ADS-CFT seems to be able to model things that people aren't necessarily sure? I don't know. But the one thing I would at least agree with Dr. Eric Weinstein on is I think there's going to be a real paradigm change coming sooner rather than later. And I think we might be in a great leap forward. And hopefully not one of those classical great leaps forwards where like we're going to do a great leap forward. what happens? Mass genocide. We should try to avoid genocide. Yeah, or at least learn from the past, maybe. And if folks aren't okay with that, then fine. Let the people that hate each other fight each other, in my opinion. Legalize dueling. But hmm, the shape of what is really there, that's probably what we're actually looking for. But to sum up my last little rant there, that professor from Harvard, it appears as if the framework of quantum theory has broadened. What do I mean by that is, I believe the key words are Markovian and Markovian matrices. It was thought that you need to have a dynamic like that. Basically, whatever the state is, it's just going to be like what the state is. It basically doesn't have necessarily a foundation of having memory built in, so to speak. Uh, it's a very inarticulate way. That's just kind of what I remember from the description when I was looking up Markovian dynamics and stuff. But what he found is apparently that's what was assumed was needed for quantum theory. But for actual quantum theory, you can actually do non-Markovian setups as well. So that basically has built in a notion of memory. So basically, in order to figure out exactly what's going on, basically, you literally probably would need the initial state or be able to sum over. Or, but the term is unistochastic. Basically, that's what it's basically me following more of like almost a classical stochastic process. Why? Well, you get your billy balls, they're doing this, they're spinning this, they have momentum, yada yada yada. All right. Now, if you have an entire system and it evolves like that, it sounds like the difference between quantum and classical mechanics may actually just really be magnitudes. And I mean, I'm very biased to that because that sounds like pretty much what we've been doing. And I think he also said you need a notion of division, and then rather than your traditional quantum mechanical process, basically it goes through and it's like, yes, you can do it this way. You can use your infinite dimensional, beautiful Hilbert space. You can totally do that. We're not taking that away. But he extended the framework, so literally you just needed like the product of Cartesian coordinates. Product of Cartesian coordinates. That sounds like multiplication. So are you saying we're going to have some stuff multiplied by some other stuff that'll generate the thing that we are observing? I mean, that would make sense to me. And I feel like if I ever get a chance to interview him, I might have to, after some warm up and stuff, and say like, pardon me, sir, but why did you take all the fun out of quantum mechanics? The big takeaway is a lot of the woo woo kind of goes away. It's like, well, this is what we would expect. And he goes through, he uses the standard quantum mechanical operator example, and he's like, yeah, but we can do it this way too. Again, not taking away, but the framework for quantum theory apparently has broadened. So there are more acceptable ways to go about it. Now, if that's true, that sounds pretty revolutionary because you're like, did nobody notice? Or maybe we just assumed because he literally said he was trying to formulate a way for his students to get a taste of quantum mechanics, and they just looked into it. He's like, I looked through the literature. He's like, I found one example of this thing, and it was in a completely different reference point, and it was just kind of like a toss away example, but they never extended to this framework because he didn't know he was supposed to include only Markovian dynamics. He didn't know any better, and he went through. He's like, well, this seems to work. And hey, it's a cool thing. But hey, Nerdy and Grizz. Hey, no way, no way. That gets run into the heart. Okay, all right. Is that what we want to go into? Oh, this reminds me of was it Bill? We had Bill Manuel. Actually, he sent me another message. I didn't read it though because I'm a terrible human being. But okay, so the standard understanding is black holes, in order to figure out what's going on inside them, whatever that is, because we have a notion of an inside and an out. Um, it's that when stuff goes in, you don't need to know the volume. If you could, it goes by the surface area. The information is encoded on the surface area of a black hole, basically by per 4 Planck lengths. And actually, Bill, it just came out just from the standard calculation, and again, I haven't seen any other folks really talking about this. Is he found a 1/log4 equivalent, because when you're taking the event horizon, the total area, basically I believe it's bit, or maybe it's actually nap. So maybe it's a 4 Planck area configuration. So if you had something like, if you got something like this, it's like, all right, you got a box. You do something like this. All right, you got Planck area. Or maybe we could be fancy and cutesy and draw a box, I don't know, like this. Oh, wait, that's our inversion little symbol there. Listen, I'm just going to say simple coincidence about this conversation. It happened to be the little thing that's in basically 288 constants in nature right there, in order for them to at least be within reasonable magnitudes, and a lot of them really kind of straight dang on the constants of nature and everything. But all right, so if you have this coordination of Planck areas, all right, so you got 1, 2, 3, 4. 4 of those areas. So if you had this configuration, which coincidentally, within the constants of nature, we only have 4 dimensions of measure expressed at any one time. Why? Because speed of light, well, that's length divided by time. Oh, h bar, that's a mass area rate. You've got mass, you've got a unit of length squared, and then that's all divided by time. And if we had time squared on the bottom, you would have energy. Why? Because that's how we have our dimensions defined, and that's how the maths seem to work out there. But yes, all right, you got stuff that falls into the black hole, and then it's going to be encoded in these Planck areas here. And what Bill found was you end up, when you plug it into the Landauer limit, so basically that is the minimal limit required to flip a bit of information. What he found from, if you take the total mass, express it in energy of the black hole, you divide it by the number of Planck lengths in there, he found that 1/log of, oh, that's an old marker. All right, get rid of this guy. So this guy, 1/, much better. All right, 1/log of 4 decay relationship there. So, I mean, maybe that should just be obvious, just because it's like, all right, you have this, because he just kept on getting out, what is it, 0.723. Yet as soon as he did that, I looked at his calculation, like Wolfram Alpha. I'm like, all right, this seems to fit. You go through the dimensional analysis, bada boom, bada bing. So it's like, well, that's interesting. So if you're going to have a notion of temperature, if we're going to believe that Hawking radiation is a thing, that seems to have a 1/log4 relationship with its total mass energy divided by the horizon and Planck area. What does that actually mean? Up to interpretation, but if you're going through and you're accounting for the different factors, if the mass comes out to be something like that, I mean, that's pretty neat. And especially, my big thing is, I think a lot of stuff that at least I go through, I'm like, oh, that's fascinating. Great. Maxwell discovered that 150 years ago. That's fantastic. But every once in a while, if you spend enough time and you have time to think, and occasionally you make a mistake, maybe because good Professor, I'm going to say Professor Jacob, because I'm butchering his last name. I apologize. But Professor Jacob's like, I literally made an error. I forgot I was supposed to assume this assumption, but things seem to work. And if things seem to work, isn't that how we make progress? Because sometimes it's happy mistake, or perhaps a discovery as well. Let's see. We absorb a lot of different stuff. Yeah. It's well, see, that's the other thing too, Jax, is people have different perspectives because it's like even as Bill was kind of going through and he was kind of explaining to me what he thought his interpretation, I'm just like, you're saying some words that just don't compute now. It's like, all right, you get that mass energy, but now you're saying it's per second. I'm not getting that per second. That just sounds like you're like 40 magnitudes off, and maybe it's just my error there. Uh, but we have different perspectives. We know what's in our head. So, as you were saying, that's one of the benefits of mathematics. You get rid of a lot of the slang because if you just try to say it in words, okay, words have very specific meanings. Whereas operators or code, basically, you should be able to hit enter and you're going to get an answer. Now, am I saying that's the optimal thing? A lot of high-end mathematicians would probably disagree with it. No, no, no. You need to physically go through and do all the calculations by either hand, or you don't want to include any floating point numbers, even though certain things like Maple and the Wolfram language and stuff like that actually do one of the most approximated things, i.e., sounds like as long as you put in significant digits, you'll have accuracy up to those significant digits, and then it will just estimate there. But that's based upon your inputs versus outputs. So we should be aware of that. Now, what was I rambling on about? Oh, Grizz asked about the whole thing about stuff going in. All right, so let's actually let me take a picture of this before I erase this all. Go through what else might be going on because I think there's a lot of more interesting things we can talk about, especially probably the case for the missing stars. Where have all the stars gone? Because we touched upon this a little bit the other day, and I think one of the other dynamics that's going to lead to revolution, I would claim, within probably astronomy and cosmology is good because there is a difference between that. A lot of people use them interchangeably, but it's like, all right, I think astronomers are universe is defined as whatever we can see, and then cosmologists like, no, 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 we got to try to account for everything over here. Why? Get the CMB. We got all this different stuff. We have our hypotheses, and they seem to be working, but James Webb seems to be conflicting with early galactic generation and everything. And it's like, where has all the dark matter gone? Now, perhaps that's not the right question. It's what the heck is all the dark matter? Okay. So I took pictures so I can actually erase this. Let's see. All right. Since I butchered about the first 10, 15 minutes of this, because I was muted, we're going to go a bit longer. So, any other fun things about black holes? Something you heard? Maybe something that I haven't even heard at all, or there's a particular study or report, or you just noticed a little quirky thing that maybe nobody else has really noticed, or at least nobody has put out there into literature or just even on the internet in general, because you'll go through and even, oh God, what was it? It was one of the papers there. Was it? It came up on like one of those engineering like blogs or sites or something like interesting engineering, and the person it's like, well, this theory of everything unites quantum mechanics and GR and everything. It's like, okay, well, people say that all the time, and then you go through, and then the person they use little quotes like, all right, well, it's basically just ratios of Planck time and Planck length. I'm like, that actually sounds right, but then you click on it, you start going through, and it's like, um. I think that this doesn't. I mean, again, I'm not a traditionally professionally trained physicist or anything like that, but it's like that. I do some calculations. I'm like, well, this number is just wrong. Like, this does not equal that at all. Like, it's like some of them it was off by. Okay, you could say maybe there's some rounding errors there, very, very liberal rounding errors, and then some of them like. No, this is just wrong, dude. Like, this isn't even of the magnitude. You're in the wrong dimension here. And then Dr. Sabine Hotzenfelder went through, and she was going through. It's like, all right, well, this is just blank. There's supposed to be something here, and she's like, yeah, this seems like the end. She brought up a very important point. She's like, yes, the unfortunate thing is this paper is either so horrible I'm not sure if they tried to have like an LLM write this, or they're trolling us. And apparently, I think within Malaysia, there was all this drama within the scientific community because people were criticizing the article. And then somebody was like, I'm going to sue you for criticizing the right thing and everything. But I remember there was one calculation that was wrong there, but then the calculation actually did. I'm like, oh, I didn't really know this. This is actually kind of cool. So that's the thing. If all of a sudden you get off on the wrong foot, kind of like doing the first 10 minutes of a live stream completely muted, maybe you'll miss something that's interesting later. But hey, that's why we do each have our own unique perspectives. It's just they're going to be shaped going to different ways and forms, and just understanding that other folks have different perspectives, and the stuff that goes on in our heads is different, and that's okay. But oh, hey, K-Shell, what's going on, my friend? Let's see. Da, 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 da. Yep, yep. Well, not always, but maybe. And then we have Nerdy, the rodent pickle wizard who's been has been using diffusion models to create magic for like years now. Before it really was the trend, I would just pop in there. I'll be like, I have no idea where you. Now have an idea of kind of how it's working. Okay, so what we were talking about? What the heck is all the dark matter? Okay, so all right. So let's say we've got our stars. La 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 la. Standard interpretation. We've got a bunch of stars going around, so we'll do this. Because somehow doing the same thing a bunch of times in a row is a lot easier than trying to draw them out individually. Because I don't know, I can only retain so much computational process that I'm supposed to be doing at any one time. Uh, However, I seem to be able to run my mouth describing that computational process as just a continuous string of just words. Okay. Okay, I wasn't trying to draw these to look like neurons, but hold on, it's a little too shiny. Well, I'll move them. We'll add a few more here. There we go. Oh, as I'm running out of this marker, looks like it maybe should be an ad for Clorox bleach to kill all the invasive microbes. All right. So you got a bunch of stars and a galaxy. We'll mark this by a galaxy. That marker's going too. All right. We'll mark the galaxy LA. All right. Blah, 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 blah. Okay. Well, apparently you start hearing some reports. It's like, and I know Anton Petrov, shout out to Anton. He's covered these things where they'll be doing different galactic surveys, and then you'll go back and stuff like a few years later and everything. It's like you're going through, and also it's like a bunch of stars are missing. WTF, mate? Where'd they all go? And you're like, oh, I don't know. Maybe they went beyond our sight. We just can't see them anymore. They sped off and we can't catch them. Maybe that's the case. I don't know. But it's like, well, why aren't all the other stars disappearing too? Didn't we see like there's a ginormous black hole or something sucking them in? Like we should be able to tell from the other things. It's like, no, they're just gone. And even shout out to Casey. Casey O'Keefe, he had brought up that apparently they seem to be discovering a lot more black holes of all different sizes, mostly stellar mass or so. Well, it seemed to be a lot more than we had suspected to begin with. And then the more recent study, which appears to be perhaps some of the best evidence we have so far of an actual direct collapse star to a black hole. Because normally we assume what happens. It's like, all right, your star gets hot, goes through its elements, it can't support itself anymore. Once you have, was it about 2 to 3 masses of the sun or so, you're going to have a gravitational collide. It's going to come down, it's going to go kablooey. And then, depending on the mass and the situation, you may have a neutron star or a black hole. Okay. Sometimes it can be hard to figure out the difference, but I think if they had about a 7.5 solar mass star, that all of a sudden it was there. It's changing in light, and it just goes. Upon further inspection, there was a bit of a boom, apparently. So they did say there appeared to be the remnants, about 3% of its mass, in a dust shell surrounding it, assuming that, all right, there was some collapse and there was probably an explosion, but not the ginormous cosmic kablooey that is like, what is it, type 1 or type 2A supernova, I believe. Just one of the big ones where it just goes one boom, and then like it outshines the entire galaxy. No, this was more of a maybe a little poof. And it's like, wait a second. Is that where all the missing stars went? Were they just of the mass range where we previously thought you needed to have ginormous explosion in order to get black holes? But what if, I don't know, maybe about a third of stars, I think the initial report said about 30% of, as of now, stars may actually end their star cycle as a dark star. They're just going to go, wait a second. So if our thoughts of, I don't know, standard galactic formations and star cycles, at least they're a bit different. Like we didn't know this could really happen, and apparently this might really happen. So if that's really happening, and it's happening about a third of the time, I don't know. Would that mean a lot of the dark matter we're seeing is just black holes? But wait, there's more. Because if there are a lot more black holes, then that would mean that at some point there were a lot more stars. And if we have stars doing their standard star things, that means they're sending out a whole lot of dang neutrinos all the time. What's a neutrino? Oh, the thing that apparently has some mass. And it seems to help the generalized standard model to start doing its thing. But it also is the other type of dark matter that we know of. That apparently new experiments to try to search for dark matter, they're in trouble, my friends. Why do I say that they're in trouble? Because we're getting in the range now that the search for axions, WIMPs, the unknown dark matter we're searching for, those dang neutrinos are getting in the way. What does that mean for a title? Scientists search for dark matter, obscured by dark matter. Listen, I haven't spent most of my life trying to think about the searching for. I do not have all that experience. I'm sure there's a lot more qualified people than myself. You should totally listen to them. Unless they were wrong. I'm not saying I'm right. I'm just going through, paying attention to recent things. It's like, well, if this seems to be a big issue, it's like, all right, we don't know where all this extra dark matter was. Well, what's the dark matter we do know? Well, black holes, which I think should be called mass holes, personally. We got black holes, and we've got neutrinos. We got some of the greatest massive things in the universe that we know of, along with the most plentiful form of dark matter that we know of, neutrinos. So that means that there's a lot more black holes. That means there's going to be a lot more dark matter in that form. And if there are a lot more black holes, we could infer there were probably a lot more stars. If there's a lot more stars, you get a lot more neutrinos, and and again, a lot of, even with the supernovas, apparently most of the energy comes out of neutrinos. I'm just saying, is it possible that the dark matter we're looking for is not the appropriate thing, and perhaps we should work better on detecting the dark matter that we know, because it might be the dark matter we're looking for? Now, plausibly, it's probably some combination of those. I could be wrong. Maybe we'll discover axions tomorrow, and everyone will be like, "Oh, memes! No, that was just a silly idea. That's not a thing right now. Look at our beautiful, shiny axion that we can't actually see because it's the dark matter that we think we're looking for." That was a whole lot of words. How's everybody doing? You survived my rant. Hold on, I'll grab coffee and we'll do I'll do commentary. But just for some housekeeping too, I'm looking to start to get some more interview series going on. If anybody knows somebody that's an interesting person talking about different stuff that we like for interviews or anything, hey, let me know. Gonna try to get my chops back into it because, well, one, it also helps me learn. And again, I'm a big fan of anime, and I look at how on point Kurt Mungle has gotten because he talks to all these people and he prepares so much. So he's learned all these things. So I feel like he's like Son Goku getting back from Namek now. It's like, oh yes, I've been through all this training, so I'm now aware of all these different things. It's power to you, brother. But Nerdy's commenting about the new neutrinos. Well, even is it Professor Neil Turok, the former head of the Perimeter Institute up there in Canada? He had even his big thing is, long story short, to just poorly summarize what he's saying is basically he rewinds GR, and apparently, if you do it in a particular way, you don't run into any problematic singularity. You just go through that point, and then you see what they'll say is a mirror universe on the other side, whatever that means. Uh, his big thing is they're thinking there's a sterile neutrino that, depending on, it's weird because some folks think if you follow the standard electron, muon, tau, they emit electron neutrinos, muon neutrinos, tau neutrinos, and you can represent those pretty well by the Cody formula, which basically muon is about 206 times more massive than the electron, and then the tau is approximately uh, uh, 30, about 3,700 times, maybe 36 and some change, 100 times more massive than the electron. It's in that ballpark. But basically, if you follow those, you can get some answers. Um, and then they also have other ways where it's like, all right, one maybe has no mass, and then the other has some mass, and the other has a lot of mass. So they're thinking, was it right-handed neutrinos? They're looking for a right-hand neutrino because apparently we only really observed left-handed neutrinos. Why might that be? Well, maybe we have a preferred direction of reality. That would be very interesting. What else we got? Well, see, that's the thing. It's the one tag that I probably had most of my life as far as an identity probably is gamer. I'm not sure if that's a good thing or a bad thing, but that's one of the reasons why this is fun to me because, well, you look at it as a game. If you have some objective, whether your objective is to down Ragnaros on Nixia, win in some Fortnite battle royal, and not get stomped on by Godzilla that apparently they don't have the right raw for unless it's Mecha Godzilla in disguise, because that would never happen. Uh you have a process, you go through something. There's going to be a lot of failure, a lot of answers. It's like, oh, that's not right. That's not right. But once you find something and you just get something, it's like this seems to be something. I don't see anyone else really talking about this. Doesn't mean it hasn't been discovered, but if folks haven't put it out there yet, it's like everyone else is more or less unknown. But as more and more folks become conscious of something, then it's like, oh, that seems like a better explanation. I can actually grok that, so to speak. I can actually like get along with the groove and feel like, oh, maybe this actually does make a difference. Maybe this is actually something that works. But oh, yes, and Upcycle is bringing up shout out to the Neutralinos. Oh, good. Part of me really wants supersymmetry to be true, just because then we could explore the entire squark field. Yes, my friends, the supersymmetric particles of quarks are squarks. This is why I stand by physicists as some of the greatest trolls of all time, because you're like, all right, I can follow that logic. It sounds silly as heck. But this is also the same community that gave us the tortoise coordinate for or what might be going on around certain black hole systems, and they literally use like a turtle shell for the torch coordinate. It was hilarious. But let's see what else we got. Yes, this is not the dark matter you're looking for. I listen. I don't know. Again, I'm conjecturing. But you just go through and it's like you listen to smart people. You hear what the smart folks are saying. But then like some of the lot of the smart folks now are saying is like, well, this seems a little different than what we were assuming. So if we plugged in what we know now, because well, hopefully we're doing better, we have better technology, we can get better measurements. Hopefully, we're doing better. But if that makes it a little bit more difficult for some of the stuff of the past, it's like, well, we're not just gonna hold on to the past because why? This is what we've always done. Has it worked recently? Just if there are other explanations, it's like I'm sure it's not like what was it? It was like what Professor Polly or somebody said. It's like I'm sure it's not like quote unquote science progresses one funeral at a time. It's like now if I were to dissect that statement, that sounds like you're saying that we need to wait until cult of personalities literally aren't there to be cult of personalities anymore in order for us to move forward. Because that doesn't really sound like science. That just sounds like standard gossip and so and so is more popular than so and so. But I think LLMs, in a way, would probably be able to try to fix that because, especially if you just use computational and programming based things, it's like, all right, does this compute? Is this shorter than this? Is this now? You can obviously use an LLM to like pat yourself on the back and say these things, and then bully it enough to get it to say whatever you want. I mean, it's not like that happens in real life with human beings. You just say, "Oh, isn't this what it is? Isn't what this is?" And you leverage either maybe not quite violence because violence is wrong unless we legalize dueling. Uh, but basically, you're leveraging, let's say, clout, charisma, cult of personality. You appeal to the appropriate authoritarians. I mean, intellectual authorities. Yes, yes. My ranting against certain structures within society that I think could be a lot better is probably a sign that we should probably wrap up the show, seeing as we have gone for now an hour and 12 minutes. So that should make up for my first 12 minutes of just rambling to myself. Gas. He's commented the gaslighting LLMs for fun and profit. Well, we'll see what happens, but I think it's going to be very interesting, and especially if you get an LLM to start reading, like, read this article, take out all the biased adjectives and everything, and just list the key points. So you'll be able to see, well, these people are for this. They had about 42 adjectives about these people are bad. These other people, they had 36 adjectives of why these people are bad. Blah blah. Oh, what are the things in common? Three things. Okay. Is that news or is that opinion? I think we should monetize news. We should monetize opinion. We should have both appropriately labeled. I think that solves a lot of problems. Oh, but my freedom of speech. Well, I mean, newspapers did that. What? It's not like your your argument in a short 10-minute video for algorithmic purposes would be completely defeated by labeling it opinion. Because then you couldn't just like send it to somebody rather than explaining yourself, and then they could just say, well, that's an opinion. Not like anybody like myself has ever just sent videos to try to highlight it. Yes, yes. I'm a terrible human being, but all right. So we did mention some things about black holes. The primary interesting thing that I think would be very that may actually pan out again, according if it's true. If black holes are basically direct collapsing, and we don't, it's happening without full-on supernovas and stuff. And this is something we can confirm, and it happens to be within a very common mass range. Yeah, I'm thinking a lot of the dark matter out there can be accounted by the dark matter we know. I mean, I guess that's not as exciting as looking for a brand new particle or something, but I mean, we're trying to do science, not trying to just provide for science fiction, are we? Because all I know is any sufficiently advanced technology is indistinguishable from magic. So if we're trying to find true magic, we should actually try to be figuring out what's going on. Why? Because that would be far more spectacular, I claim. Nerdy, reality may or may not have already done that for us. But stay tuned next time, so we'll get into that. Somebody remind me. But with that all, everybody have yourself a merry holiday. Hopefully you have time to spend with some ones that you love, you care about, and other than that, take care of yourselves, everybody. It's a wacky and wild world out there. Peace out.